Alright guys, so we're going to start reviewing for your test on Friday, February 15th. This is the second test of the third quarter. It's mainly on trig stuff. Okay, so for the first one, solve for the missing variable using right triangle trig. This is actually what you guys did in geometry. We didn't spend a lot of time during doing this. But right triangle trig, that's SOHCAHTOA. So here, if this is my angle, this 47 degrees, 24 is the hypotenuse, X is adjacent. So in SOHCAHTOA, the two that use A and H is the cosine. So you have cosine of the angle, which is 47 degrees, is equal to adjacent over hypotenuse. Put this over 1. For this, your calculator should be in degree mode because this is 47 degrees. When you cross multiply, you get x is equal to, in your calculator, you have to type in 24 times the cosine of 47 degrees. Again, degree mode. When you do that, this doesn't tell you where to round to, so really you should write out the whole thing. You get 16.367960664. Okay, for number 2 and 3. If the following points are on the unit circle, the points are on the unit circle. Whenever you see on the unit circle, you have those 3 rules. Those 3 rules are that the sine of theta is equal to the y value. The cosine of theta is equal to the x value. And the tangent is sine over cosine, or y over x. Okay, so for number 2, I'm just doing sine, cosine, and tangent of theta. I don't actually have to find what theta is. So to find the sine of theta is equal to the y value, which is 3 over 5. Cosine of theta is equal to the x value, is negative 4 divided by 5. And then the tangent of theta, I have 3 over 5 divided by 4 over 5. I can do keep, change, and then flip. These two cross out, and I get 3 divided by 4 for the tangent of theta. And that's it. That's all it wants. For number 3, same thing, just different numbers. With the radicals, it might be a little bit more confusing, but it's really just the same concept here. So I want to find the sine of theta, cosine theta, and tangent of theta. I don't know what theta is, but because I have the point, I know that the sine of theta is the y value. The cosine of theta is the x value. So negative 1 over 3. And then the tangent of theta we have to do a little bit more work for. So in this case, it's 2 square root of 2 over 3 divided by negative 1 over 3. So I'm going to do keep, change, and then flip. If you put the negative in the bottom, it's not going to matter. Not a big deal. These cross out, and I end up with negative 2 square root of 2 as the tangent of theta. Numbers 4 and 5, it's looking for 4 and 5. You're looking for the x and the y value if the point is on the unit circle. This is what we just did, but going the opposite way. Okay, I'm given theta, right? 245 degrees is my theta value. And now I have to find what the point is. I have to find x and y. So I use those rules that we just did. I use the cosine of 245 for the x value, right? Because 245 is theta. And then the sine of 245 for the y value. The cosine of 245, type it into your calculator. This says I'm rounding to the nearest hundredth, is negative 0.42. And then the sine of 245 is negative 0.91, which makes sense because I know in quadrant 3, cosine and sine are both negative. If this said find point A, x comma y, an exact value, you would have to look to see that these decimals would be on that list of our fancy decimals that we need to memorize. For number 5, same idea. Point A is on the unit circle, so it follows those rules. I have to do the cosine of 140 and then the sine of 140 to figure out what that point is. So when you plug it in and you round, you get negative 0.77, comma 0.64. If you don't put the 0, it's not a big deal. And then numbers 6 through 8 want the exact value. So you need to memorize your decimals. So the decimals that I ask you to memorize, the square root of 3 divided by 3 is equal to 0.5773. The square root of 3 divided by 2 is 0.8660. The square root of 3 is 1.7320. And then the square root of 2 over 2 is 0.7071. And then you guys know that 0.5 is 1/2. But if you write 0.5, that's still the exact value, so that's not a problem. So these, you can type all of them into your calculator. However, these are all degree measurements, which means your mode should be in degrees. When I type in for number 6, these are all sine. When I type in the sine of 90, I get 1. The sine of 30 is 1/2. The sine of 60, you type it and you get 0.8660, which is right down here. This is the square root of 3 over 2. And then the sine of 270 is negative 1. Number 7, I type in the cosine of 60, I get 1/2. The cosine of 45 degrees, I get 0.7071, which is really the square root of 2 over 2 because this says exact value. The cosine of 180, negative 1, and then the cosine of 90, 0. Number 8, cosine of 0, I get 0. Not cosine. Tangent of 0, I get 0. Tangent of 270, I get an error message. That is because the tangent of 270 is undefined. The tangent of 45, I get 1. And the tangent of 30, I get 0.5773, which is the square root of 3 divided by 3. For number 9 and 10, we are rewriting the following as the function of a positive acute angle. And this means reference angle. Okay? Reference angle is how far away from the x-axis you are at that angle. So here, 300 degrees. 300 degrees is over here somewhere. It's in quadrant 4. So I have to see how far it is from the x-axis. It's going to be 60 degrees. So the tangent of 300 is the same number as the tangent of 60, but then I have to see if there's a sign change. The tangent of 300, that's in quadrant 4, which is where tangent is negative. So I have to negate the tangent of 60. Okay, same idea for number 10. For number 10, 225 degrees is in quadrant 3. So how far away from the x-axis is it? I would do 225 minus 180, and I would get 45 degrees. So the sine of 225, the number, the absolute value of the number, I should say, is really the same thing as the absolute value of the sine of 45. Absolute value meaning the sign doesn't matter, like the positive or negative. So the sine of 225 is a negative number because we are in quadrant 3, which means I have to negate in front of the sine of 45. For number 11 and 12, here you're given what the cosine and the tangent are, and it asks you to find theta. So in this case, what I want you to type into your calculator, remember I said you might remember this from geometry, depending upon who you had. If you're missing the degree, right, theta is the degree. If you're missing the degree, hit the second key. So what you're actually going to type into your calculator is cosine. You're going to press second, cosine, which brings you to this. And then you're going to ignore the negative. That way it gives you the reference angle. When you type this into your calculator, you end up getting 70, which is my reference angle. I don't want the reference angle, though I want theta. So 70 degrees in quadrant 3, right, because that's what my question says, I would go 180 and then another 70. So 180 plus 70 tells me that theta is equal to 250 degrees. That's it. Same idea for number 12. I'm going to press second, tangent, ignore the negative, that way it gives you the reference angle. And your reference angle here is going to be about 20 degrees. However, we're in quadrant 2, so 20 degrees in quadrant 2 tells me this is 20, which means this, theta, is equal to 160. So 180 minus 20 degrees is 160 degrees. For number 13 and 14, this combines what we just did in 11 and 12, along with what we did for numbers 2 and 3 previously. Okay, so this is like a mixture of numbers 2 and 3 and 11 and 12. For questions 13 through 14, given the following points on the unit circle, find sine of theta, which will be my y value, cosine of theta is the x, and tangent, which is y over x. Then it says, then find theta rounded to the nearest degree. So then you're going to do what we just did in 11 and 12 up here. So for number 13, the sine of theta is equal to the square root of 3 over 2. The cosine of theta is equal to negative 1 over 2. And then the tangent of theta, I have a little bit more work for. I have the square root of 3 over 2 divided by negative 1 over 2. Keep, change, flip. These cancel. I get negative square root of 3. Okay, now I have to find theta. So I can type any of these. You know how up here for numbers 11 and 12, you were only given one thing. You were given the cosine of theta is this. Down here, you're given 3. No matter which one you do, you're going to end up getting the same reference angle, so it does not matter. So if I type in second sine of the square root of 3 divided by 2, I get that my reference angle is equal to 60 degrees, which you probably should know from that special angle chart. The sine of 60 is the square root of 3 over 2. The cosine of 60 is 1 over 2, and then the tangent of 60 is the square root of 3. However, I have to think about what quadrant I'm in. Go back to the point. If you were to graph this point, this is a negative x and a positive y. That would be somewhere over here in the second quadrant. So this is what I'm looking for. Right? This is my angle here. So I would do 180 minus 60 to tell me that theta is equal to 120 degrees. For number 14, same idea. Sine, cosine, super easy. Sine of theta is negative 3 over 5. Cosine of theta, negative 4 over 5. Tangent of theta is equal to negative 3 over 5 divided by negative 4 over 5, which is negative 3 over 5 times negative 5 over 4. These cancel. Negative 3 times negative 1 is 3 divided by 4 is the tangent. So now what I'm doing, I'm trying to find what theta is. I can type any of those 3 into my calculator. Again, ignore the negative if you type in sine or cosine, and it tells me that my reference angle is approximately 37 degrees. This says rounded to the nearest degree for theta. Okay, so reference angle is 37 degrees. I have to think about what quadrant I'm in. Negative x, negative y values are going to be in quadrant 3. So this here is 37 degrees, but I want the entire thing starting at the initial side over here. So I would do 180 plus 37 to tell me that theta is equal to 217 degrees. Numbers 15 and 16. Convert the radians into degrees. This is super easy. The big one that you have to remember, right, radians is just another way that we measure angles. Kind of like the how I keep saying that feet is another way that we measure distance, along as well as yards, as well as meters. There's different units of measurement. Same thing for angles. It's just you guys are so trained with degrees, you know what degrees are. Radians, it's another way to determine how big an angle is. So the big conversion that I told you guys that you should know is that 180 degrees is equal to pi radians. If you know this, this helps you for these two questions, because for these, all you have to do is replace the pi symbol with 180. You're replacing the radians with the degree measure. And then when I clean this up, I do it right in my calculator. I find that 4 pi over 3 is 240 degrees. Number 16, same idea. Replace the pi symbol with 180 degrees, because pi radians is 180 degrees. And then I could type it right into my calculator, and this is 165 degrees. For numbers 17 through 19, this deals with what we were doing on Monday and Tuesday in class, or Monday and Wednesday in class, if I didn't see you in time before we had the half day on Tuesday. For number 17, you are evaluating these. Evaluating is really the same thing that you've been doing all along with evaluating. However, there is an extra step with trig functions. The extra step with trig functions is that you have to watch the mode. Okay? 17, 18, and 19, these are all radian measurements because of you can tell because of the pi. Plus there's no degree symbol. So these are all radian measurements, which means my calculator should be in radian mode. So make sure you change that. Okay? Then what I'm going to do, I'm not going to type the entire thing into my calculator. I'm going to type in just the trig function. So I'm going to type just this in. Okay, so when I clean it up, I have 3 times some number and then minus 4. When I type that into my calculator, nice clean number, I end up getting 0. So then my final answer, 3 times 0 is 0, minus 4 is just negative 4. For number 18, same idea. I'm in radian mode like I was for number 17. Always make sure that you check it though. So I'm going to do 5 minus 8 times the tangent of 4 times pi over 6. I'm not typing the entire thing in. I'm typing this in. When I type that in, I end up with negative 1.7320, which is one of my special decimals. So it's negative square root of 3. This is then 5 plus 8 square root of 3. I cannot add these two because the 8 is attached to the square root of 3. It's kind of like 5 plus 8x. How you can't add them because they're not like terms. The 5 doesn't have a square root of 3 attached to it, so I cannot add the two of them. And then lastly, number 19. Number 19, secant, that is a reciprocal function. Okay? So we have negative secant of 3 pi over 4 plus pi, and then minus 4. I can't type this into my calculator because there is no secant function. However, what I can type into my calculator is cosine, because that is the reciprocal function of secant, right? C goes to S, S goes to C. So cosine goes to secant. The reciprocal of cosine is secant. So I'm going to type in the cosine of all of this. And when I do that, I end up getting the square root of 2 over 2. However, for the reciprocal function, I have to flip that around. So this is negative 2 over the square root of 2, and then minus 4. I can't have this though. I can't have this because I can't have a radical in the bottom. So I clean it up. I get negative 2 square root of 2 over 2 minus 4. These two can cancel, and I really end up with negative square root of 2 minus 4. But you're probably going to see that the radical come at the end. So I just flipped the order around. Not a big deal, though. And then lastly, I did put a few review questions on there. Once every year, once we hit trig, I try to put more review questions on your review sheets. That way, because there's a lot more material now that you guys need to memorize. So I try to help you guys out for your test what you need. So for number 20, find the equation of a curve that's equidistant from the point and the line. This is a parabola. A parabola. So you need to also know this formula. I told you months ago that this will always come back. Where h and k is the vertex of the parabola, this is a k, and p is the distance from vertex to focus in that order. This is not your vertex. This is not the p-value. So what I suggest that you do every single time is that you graph this. So I go over 8. And then up 4. This is the focus up here. Then my directrix is right here. Okay? So this is it doesn't have to be a perfect drawing. It's always just a rough sketch. That way it helps me actually see where I am. So that's why I tell you guys that you should also think about doing it if you get confused. So the vertex is the point that's directly in the middle, so I can count spaces if I want, but the point that's in the middle is right here. That point is 8 comma negative 1. This parabola is concave up because the parabola has to it has to look like it's going around for a hug around the focus. It also can't be going through the directrix at all. And then the p-value, because it's concave up, p is going to be positive. And then you count from vertex to focus how many you go up. In this case, I go up 5. So when I plug this in, I get x minus 8 squared equals 20 y plus 1. That's it. For number 21, I put this on your last test, I believe. If you follow the rule, it's really not, it looks a lot more confusing than it is. But think of it, try to always do it this way. The cubed root of a to the 5th is a to the 5/3 power. And then the square root of a to the 7th is a to the 7/2 power, raised to the negative 1/2. These in here are both a's. They have the same base. So to make them one thing, you would do division. And the way that you divide variables is by subtracting the exponents. So in my calculator, when I do 5/3 minus 7/2, I get negative 11/6. And that's still being raised to the negative 1/2 power. So now, though, I have to do power to power, which means I multiply. When I multiply, I get 11 divided by 12. You can leave that as your answer, or this is also the 12th root of a to the 11th. These two are the same thing. 22 and 23, we have systems. So for number 22, this is a quadratic linear system, right? This is the quadratic, that's the linear. Set them equal to y, and then set them equal to each other. You're going to use substitution for this. So this is x squared minus 2x minus 1 equals x plus 3. And now you just have a quadratic equation. Set it equal to 0. And then solve. So I'm going to factor this. So I do master product. You do the whole thing. Your final answer is x minus 4 times x plus 1 equals 0. Your final factoring answer, not your final answer, I should say. So this gives me x equals 4, and this gives me x equals -1, which is nice, but the answer to a system, you need x and y, and possibly z. So you need answers for every variable. So I plug this in to the linear to get the y values. So when I do y equals x plus 3, I get 4, 7 as 1. And the other one, x plus 3, gives me -1, 2. Number 23. This is a circle linear system. So a little different, because if you solve for y in the circle, you're going to end up doing the square root, and it's just going to be a mess. So instead, you're going to solve for one of your variables in the linear and then plug that into the circle. So I'm going to solve, I don't want to have to divide everything by 4 because it's not going to be clean numbers. So instead I'm going to solve for x and divide everything by 2. So this is 2x equals -4y minus 10. So x is equal to -2y minus 5 when I divide by 2. So when I plug that in, I have x squared, so -2y minus 5 squared plus y squared is equal to 25. So be careful with this, because this is always a big problem. You have to double distribute this. So write it out twice if you have to. But that's what you get, and then you still have plus y squared is equal to 25. This is really just a quadratic equation, but instead of x's, you have y's. So you're going to set it equal to 0. So this is 5y squared plus 20y equals 0. I'm going to factor this. So I'm going to take out a GCF of 5y, and I'm left with y plus 4. So on this side I get y equals 0, and over here I get y is equal to -4. But I still need the x values now. So x is equal to -2 times the y value minus 5. That point is going to be -5, 0. Make sure x's come first. And then over here, x is equal to -2y minus 5. So this point is going to be 3, -4. And then the last question down here. This is talking about what we just did. You deposit $8,500 into an account that pays interest compounded quarterly. I still need to know all of these formulas. This is A equals P times 1 plus R over N raised to the NT. Algebraically determine how long, that is T, it will take for the account to obtain whatever it is. So your equation that you set up is going to be A is 11,400, right? It's the final amount, equals the starting amount, how much you originally put in. And you have 1 plus R is 0.021 divided by N, which is quarterly, so it's 4 raised to the 4T. You divide everything, you divide both sides by 8,500, and you get 1.34117. Again, you have to write at least 5 decimals. Keep the number in your calculator. Is equal to, I'm going to actually do this in my calculator to clean it up, and I get 1.00525 raised to the 4T. So now I log both sides. I bring the 4T out front over here. Divide both sides by the log of 1.00525. Remember, you're keeping all of these numbers in your calculator. And you get 56.06039 is equal to 4T. Still haven't rounded. I keep the number in my calculator. Divide both sides by 4. And I get T equals. This is my answer. So now I can round to the nearest tenth. T equals 14.0 years. Okay? Extra help will be on Thursday after school. Again, if you will not be here on Friday, you should have made an appointment with me to take your test earlier. Okay, I don't want you taking it after break. If you have any questions, please come to Extra Help on Thursday after school and I will answer them. Have a good night.